What if Project Bluebeam wasn't a conspiracy theory, but a leaked blueprint? In the 1990s, researcher Serge Monast warned of Project Bluebeam, a supposed plan to project illusions in the sky that would convince humanity to surrender sovereignty to a new world order, promising protection from cosmic dangers. Most dismissed it as paranoid fantasy, but now, as 3I-ATLAS races toward us from interstellar space, something doesn't add up. This comet shows unusual chemical signatures, strange polarization behavior, and arrives exactly when conspiracy theories about sky deceptions have reached critical mass. Coincidence? Maybe. Or maybe we're witnessing the field test for something far more sophisticated than anyone ever imagined. The data patterns we've found raise questions that no one in official astronomy seems willing to address. The implications are staggering. Tonight, we walk through evidence versus imagination, keeping our feet planted firmly on scientific ground, while our eyes remain fixed on the impossible, the beginning of Project Bluebeam. Prepare yourselves. We begin. Part 1. The question. Let me paint you two pictures, and you tell me which one keeps you awake at night. Picture 1. Project Bluebeam, a 1990s conspiracy theory claiming that shadowy forces plan to stage magnificent illusions across our skies. Holographic deities, false messiahs, all orchestrated to shepherd humanity toward a single world order. No credible evidence exists for such a program, yet the theory persists, morphing and adapting to every unusual light in the heavens. Picture 2. 3I-ATLAS, a genuine interstellar comet, only the third such visitor we've ever confirmed. It's real, it's here, and it's putting on quite a show as it awakens under our sun's influence. The 3I designation marks it as our third confirmed interstellar object, following the mysterious Oumuamua in 2017 and the more conventional Borisov in 2019. Here's what makes this moment so peculiar. The rarity alone should stagger you. Interstellar objects are cosmic lottery tickets. We've had telescopes scanning the skies for decades, and we've found exactly three. Three visitors from the star-swept depths of the galaxy, each carrying secrets from alien solar systems. And now, as 3I-ATLAS grows its magnificent tail in our inner solar system, the internet buzzes with whispers of manufactured spectacles and government deception. The stakes couldn't be clearer. This comet is approaching perihelion, its closest point to the Sun, around October 29th through 30th, 2025. During December, it will make its nearest approach to Earth at roughly 269 to 275 million kilometers away. That's about 1.8 astronomical units, or roughly 700 times the distance to our Moon. Close enough to study with our finest instruments, far enough to pose absolutely no danger. But timing, as they say, is everything. 3I-ATLAS has arrived during a decade of heightened conspiracy thinking, when every unusual video uploaded to social media gets tagged with blue beam before anyone bothers to check if it's real footage, computer graphics, or simple atmospheric optics. We live in an age where breathtaking drone light shows get mistaken for government mind control experiments, where lens flares become evidence of interdimensional portals. Here's our promise for the next hour. We will label speculation as speculation. We will quote credible observatories and their actual measurements. When scientists disagree, and they do, we'll acknowledge those disagreements honestly. The guiding principle remains simple. Extraordinary claims require extraordinary evidence, and we'll show you exactly where that evidence does and doesn't exist. Our journey begins with the conspiracy itself, the origins of Project Bluebeam and why it captures imaginations. Then we'll trace the history of interstellar visitors, examine what we actually know about 3I-ATLAS from telescopes around the world, and explore why human beings have always linked comets to omens and prophecies. Finally, we'll discover how to stay both grounded and wonder-filled in an age of infinite information and finite truth. But first, let me offer you some calm reassurance. NASA, the European Space Agency, and observatories from Chile to Hawaii are tracking 3I-ATLAS with the same methodical precision they apply to every celestial object. Multiple independent teams have confirmed its trajectory, composition, and behavior. Nothing in the data indicates danger, deception, or deviation from well-understood comet physics. We're here to learn, not to panic. That said, some intriguing controversies swirl around this visitor. Its chemical signature shows an unusually high ratio of carbon dioxide to water, strange but not unprecedented. Early polarization measurements suggest unusual dust properties. There's chatter about mini-probes and craft-like behavior, claims that range from mainstream scientific speculation to the fringes of credibility. We'll examine each assertion with the same careful scrutiny, separating peer-reviewed findings from internet conjecture. The central question remains tantalizingly complex. Could a genuinely rare interstellar object become woven into a decades-old myth about sky illusions? Can real science coexist with persistent conspiracy in our collective consciousness? And what happens when legitimate wonder meets manufactured fear? Social media algorithms love a good mystery, especially one that combines cutting-edge astronomy with paranormal possibilities. Every video of 3I-ATLAS gets dissected, enhanced, and reinterpreted through a dozen different lenses. Some viewers see a natural comet awakening to the sun's warmth. Others detect patterns that suggest intelligence, control, or deception. The same pixels tell radically different stories depending on who's doing the telling. Consider this. We've never had better tools for studying interstellar visitors. The James Webb Space Telescope, the Hubble Space Telescope, ground-based observatories with adaptive optics that can peer through atmospheric turbulence. We're living through a golden age of astronomical instrumentation. Yet, paradoxically, we've also never had more sophisticated tools for creating convincing illusions. Computer graphics can render photorealistic spacecraft, holographic displays can project images into thin air, and synchronized drone swarms can paint temporary masterpieces across the night sky. The convergence isn't coincidental. Real technology enables both genuine discoveries and elaborate hoaxes. The same digital sensors that capture authentic spectra from distant comets can be fooled by clever computer-generated imagery. The same social networks that spread legitimate scientific findings also amplify unfounded speculation at the speed of light. Tonight, we're going to slow things down. We'll examine each claim methodically, trace each piece of evidence to its source, and maintain healthy skepticism without sliding into cynicism. The goal isn't to debunk wonder, quite the opposite. Real cosmic visitors are far more magnificent than any conspiracy theory could imagine. The universe doesn't need human enhancement to inspire awe. As we prepare to dive deeper into this modern mystery, remember that both stories, Blue Beam and 3I-ATLAS, reveal something profound about human nature. We are pattern-seeking creatures living in an age of infinite information. We crave both rational explanations and transcendent meaning. Sometimes those desires align perfectly with reality. Sometimes they create their own reality. The show begins now, and the first question we must answer is this. When faced with genuine mystery, do we reach for the telescope or the conspiracy theory? Tonight, we're choosing both, but only one will survive contact with the evidence. Part 2. A visitor from the stars. What makes an object interstellar sounds almost philosophical until you see the mathematics. It's not about distance or origin story, it's about trajectory. Every planet, asteroid, and comet in our solar system follows an elliptical path, bound by the sun's gravitational embrace. But some visitors trace hyperbolic curves, mathematical signatures of objects that came from elsewhere and will return to elsewhere, following paths that never close, never repeat. 3I-ATLAS earned its designation through cold, hard orbital mechanics. The 3I prefix marks it as our third confirmed interstellar object, a sequence that began with the enigmatic Oumuamua in 2017 and continued with the more conventional Borisov in 2019. Each discovery expanded our understanding of what drifts through the galaxy between the stars. The story began on July 1st, 2025, when the ATLAS survey telescope in Chile detected a new moving object against the star field. ATLAS, the Asteroid Terrestrial Impact Last Alert System, wasn't specifically hunting for interstellar visitors, but its wide-field cameras and automated detection software caught something unusual. Within 24 hours, the Minor Planet Center had confirmed what the preliminary calculations suggested. This wasn't just another solar system resident. July 2nd brought official confirmation. The object received dual designations, 3I-ATLAS for its interstellar nature and C/2025N1 for its cometary behavior. That dual identity tells you everything about why this visitor has captured scientific attention. It's simultaneously exotic and familiar, alien and comprehensible, but here's where the story gets interesting. Hyperbolic trajectories aren't just mathematical curiosities, they're smoking guns. When an object arrives at our solar system with enough speed to escape again, it announces its foreign origin as clearly as a passport stamp. 3I-ATLAS is moving fast, really fast, with velocities that scream, "Not from around here." Currently, as autumn 2025 approaches, 3I-ATLAS is developing both a tail and a growing coma, the fuzzy envelope of gas and dust that forms when solar heat begins sublimating ices from the nucleus. This awakening process transforms it from a dark, invisible chunk of frozen material into an active comet bright enough for ground-based telescopes to track and study. The timeline ahead promises spectacular science, if not spectacular viewing. Perihelion, the closest approach to the Sun, will occur around October 29th through 30th, 2025, at roughly 1.36 to 1.4 astronomical units. That's inside Mars's orbit but comfortably outside Earth's, positioning the comet for maximum solar heating without venturing into truly dangerous territory. From Earth's perspective, the timing creates both opportunity and frustration. During the peak heating phase around perihelion, 3I-ATLAS will be positioned on the far side of the Sun, largely hidden from our telescopes by solar glare. It's the astronomical equivalent of the best show in town happening behind a curtain. But patience pays dividends. By December 2025, the comet will emerge from behind the Sun and make its closest approach to Earth at approximately 1.8 astronomical units, or about 270 million kilometers away. To put that distance in perspective, imagine standing in New York and trying to see a basketball in Los Angeles. Now multiply that challenge by several million, and you'll understand why even close approaches require sophisticated instruments to study properly. 3I-ATLAS will never become a naked-eye spectacle for casual observers, but it will remain well within range of professional telescopes and dedicated amateur astronomers. The scientific community has mobilized impressive resources to study this visitor. The Gemini South Observatory in Chile has been tracking its development with high-resolution imaging. The James Webb Space Telescope turned its infrared eyes toward the comet on August 6, 2025, capturing detailed spectra that reveal the chemical fingerprints of its outgassing. The Hubble Space Telescope continues monitoring its evolution, while ground-based observatories around the world contribute complementary observations. What they're finding challenges some assumptions while confirming others. The comet's composition, as we'll explore in detail later, shows a remarkable dominance of carbon dioxide relative to water, unusual compared to most solar system comets but not unprecedented. Water vapor has been detected along with carbon monoxide, carbonyl sulfide, water ice, and various dust components. It's a chemical treasure trove that offers insights into conditions in alien star systems. The comet also made headlines with its relatively close pass by Mars on October 3, 2025, approaching within roughly 28 million kilometers of the red planet. While that sounds alarmingly close, it's actually routine from a celestial mechanics perspective, about 75 times the distance between Earth and Moon. Still, the Mars encounter captured public imagination and reminded everyone that we're watching a genuine cosmic visitor, not just another dot of light. No threat exists to Earth, Mars, or anything else in our solar system. The closest 3I-ATLAS will come to our planet is about 1.8 astronomical units in December, roughly 270 million kilometers, or about 700 times the distance to our moon. That's not even close in astronomical terms. You're in more danger from the coffee you're drinking while listening to this than from any interstellar comet. But here's what makes this visitor genuinely extraordinary. Its very existence expands our understanding of what's possible between the stars. Interstellar space isn't empty. It's filled with wandering worlds, rogue comets, and cosmic debris ejected from distant star systems. 3I-ATLAS represents our third confirmed sample of that hidden population, a messenger from processes and conditions we can barely imagine. The fact that we've now detected 3 interstellar objects within 8 years suggests we're just beginning to catalogue a vast population of wanderers. Improved sky surveys, better computers, and more sensitive detectors are revealing what was always there, but never seen. We're living through the opening chapter of interstellar archaeology, learning to read the stories written in ice and rock by alien solar systems. As 3I-ATLAS continues its journey toward perihelion and beyond, it carries with it not just the chemicals and dust of its formation, but also our hopes and fears about what lies beyond our cosmic neighborhood. Every measurement, every spectrum, every image adds another piece to the puzzle of how planetary systems form, evolve, and occasionally lose their most distant children to the galaxy at large. The comet will spend only a few months in our inner solar system before racing back toward interstellar space, accelerated by its close encounter with our Sunday. By late 2026 or early 2027, it will fade beyond the reach of our telescopes, carrying its secrets back into the cosmic dark. We have one chance to study this visitor properly, one window to learn what distant star systems can teach us through their frozen ambassadors. But already, in these early months of study, 3I-ATLAS has accomplished something remarkable. It's forced us to confront the reality that our solar system exists within a larger community of worlds, connected by the slow exchange of cosmic refugees across impossible distances and unimaginable time. Part 3. The Blueprint of Deception, Project Blue Beam Basics. The story begins with a Canadian journalist named Serge Monast, though you might say it began with humanity's oldest fears dressed in modern clothes. In the 1990s, Monast popularized what he called Project Blue Beam, a supposed NASA and United Nations conspiracy to stage the most elaborate deception in human history. According to this theory, advanced holographic technology would paint false gods across the sky, synthetic telepathy would whisper divine commands into unsuspecting minds, and a fake messiah would emerge to unite the world under authoritarian rule. No credible evidence has ever surfaced for such a program, but that hasn't stopped the theory from evolving, adapting, and finding new life with each generation of believers. Like a virus that mutates to survive new environments, Project Bluebeam has morphed to incorporate every technological advancement and geopolitical shift of the past 3 decades. The supposed blueprint reads like science fiction crossed with religious apocalypse. Monast described 4 phases of deception, each more elaborate than the last. Phase 1 would involve artificially triggered earthquakes and other natural disasters designed to uncover archaeological evidence that would challenge existing religious beliefs. Imagine ancient ruins suddenly revealed by convenient earthquakes, each discovery carefully orchestrated to shake the foundations of faith. Phase 2 promised the main event, massive 3-dimensional holographic projections beamed directly onto the atmosphere, creating the illusion that each culture's religious figure had returned. Jesus over Christian nations, Buddha over Buddhist regions, Muhammad over Islamic territories, a celestial puppet show designed to fulfill prophecies while actually manufacturing them. The technology required would be staggering. Laser systems powerful enough to ionize atmospheric particles at precise coordinates, computer systems capable of rendering photorealistic divine figures at continental scales, and coordination networks spanning the globe. Phase 3 would supposedly deploy synthetic telepathy, direct electromagnetic manipulation of human brains to implant thoughts, voices, and visions that would seem to come from the divine figures projected in Phase 2. Citizens would hear their gods speaking directly to them, bypassing all critical thinking and rational analysis. The neurological precision required would make current brain-computer interfaces look like stone tools. Finally, Phase 4 would reveal the true purpose. The projected figures would announce their unity, declare a new world order, and install a single leader, the false messiah, to rule over a consolidated global government. All traditional religions would be dissolved, all national boundaries erased, all individual freedoms subsumed under the new regime. It's important to distinguish Project Bluebeam from Project Blue Book, the genuine United States Air Force program that investigated UFO sightings from 1952 to 1969. Blue Book was real, extensively documented, and dealt with unexplained aerial phenomena through conventional investigation methods. Bluebeam, by contrast, exists primarily in the realm of speculation and fear. The theory's persistence reveals something profound about human psychology. It weaves together multiple anxieties, surveillance technology, religious manipulation, political control, and scientific deception into a single narrative that claims to explain everything. This comprehensiveness makes it appealing to minds seeking patterns and meaning in chaotic events, even when those patterns don't actually exist. Modern technology adds uncomfortable plausibility to certain aspects of the theory. We can indeed create impressive illusions in the sky. Intel set a world record with 1,218 synchronized drones painting precise patterns against the night sky during the 2018 Winter Olympics. Similar displays have become routine for major events, advertising campaigns, and artistic installations. The technology exists, it's legal, and it's becoming more sophisticated every year. But there's a vast gulf between coordinated drone shows and atmospheric holographic projections visible across continents. Laboratory demonstrations of acoustic and optical levitation can create small three-dimensional images suspended in mid-air, but scaling such technology to cover entire regions would require energy sources and coordination systems that don't currently exist in any practical form. The physics alone present insurmountable challenges at the proposed scale. Similarly, our understanding of neuroscience has advanced dramatically since the 1990s. We can indeed stimulate specific brain regions with electromagnetic fields, and some research has achieved limited synthetic telepathy through direct neural interfaces. But the precision required to implant complex thoughts or voices into unwilling subjects across large populations would require technology centuries beyond our current capabilities. Yet, Project Bluebeam endures and evolves, finding new relevance with each technological advancement and social upheaval. Social media amplifies its spread, allowing believers to find each other across vast distances and share evidence at unprecedented speed. Every unusual atmospheric phenomenon gets tagged as potential blue beam activity. Every government space program draws suspicion. Every advance in projection technology or neuroscience research feeds the theory's growth. The conspiracy has become remarkably adaptable. Originally focused on religious manipulation, modern versions incorporate alien invasion scenarios, climate change deceptions, and pandemic control measures. Bluebeam has become less a specific theory than a flexible framework for interpreting any large-scale, coordinated event as potentially fabricated. This adaptability explains why 3I-ATLAS has attracted Bluebeam speculation. Here's a genuinely unusual celestial event, our third confirmed interstellar visitor, arriving during a period of heightened conspiracy thinking. The comet's growing tail and increasing brightness create exactly the kind of spectacular sky show that Bluebeam theory suggests might be artificially produced. Never mind that multiple independent observatories worldwide are tracking the object with different instruments, publishing their methods and data openly, and inviting scrutiny from the global scientific community. The theory's proponents argue that this transparency could itself be part of the deception, that the entire astronomical establishment might be complicit in staging the illusion. Such reasoning creates an unfalsifiable hypothesis. Any evidence against the conspiracy becomes evidence for its sophistication, its intellectual quicksand that swallows counterarguments and grows stronger with each attempted refutation. But here's what makes Project Bluebeam genuinely dangerous as a conspiracy theory. It encourages people to distrust their own senses and dismiss legitimate scientific findings. When someone believes that spectacular sky events might be artificially generated, they lose the ability to appreciate genuine cosmic phenomena. The real universe, filled with interstellar visitors, stellar explosions, and planetary alignments, becomes indistinguishable from imagined deceptions. Real spectacles in the sky are becoming more common, but they're usually terrestrial rather than celestial. Drone light shows can create temporary artworks against the night sky. Laser projection systems can illuminate clouds and atmospheric particles. Military exercises sometimes involve flares, plasma experiments, or unusual aircraft that create genuinely puzzling displays for ground observers. These legitimate technologies provide just enough reality to keep conspiracy theories alive. When people see coordinated lights moving in formation overhead, they're not necessarily wrong to think human technology is involved. They might be witnessing a commercial drone show or military exercise. The problem arises when they assume that all unusual sky phenomena must be artificial, losing the ability to distinguish between human-made spectacles and natural cosmic events. Project Bluebeam represents more than just another conspiracy theory. It's a lens through which some people interpret reality itself. That lens filter colors every unusual event, every government announcement, every scientific discovery. It transforms genuine wonder into manufactured suspicion, turning the universe's most magnificent displays into evidence of human deception. As we continue our examination of 3I-ATLAS and its intersection with Bluebeam speculation, remember this fundamental truth. Conspiracy theories are stories people tell about power and control. Sometimes those stories reveal real problems with institutions and authority. But sometimes they prevent us from seeing the actual universe in all its strange and magnificent reality. Part 4. The Sky as a Screen. Why the Heavens Make Perfect Myths. The sky has always been humanity's greatest movie screen, projecting our fears and hopes onto a canvas larger than imagination. Long before anyone conceived of Project Bluebeam, our ancestors looked up and saw gods, demons, portents, and prophecies written in light and shadow. What's changed isn't our tendency to find meaning in celestial events, it's our sophisticated tools for creating counterfeit heavens. Consider the panic of 1910, when Halley's Comet returned for its regular 76-year visit. Newspapers breathlessly reported that Earth would pass through the comet's tail, potentially exposing our planet to deadly cyanogen gas. Never mind that the tail's density was barely above vacuum, fear spread faster than facts. Entrepreneurs sold anti-comet pills and gas masks to terrified citizens. Some people sealed their windows and doors, others held comet parties, and a few committed suicide rather than face poisoning from space. The 1910 comet panic reveals something crucial about human psychology. We project agency onto random events, especially when they're rare, visible, and poorly understood. A comet doesn't just appear in the sky, it appears for a reason, carrying meaning, delivering messages, presaging change. This tendency toward what psychologists call apophenia, the perception of meaningful patterns in random information, helped our ancestors survive by detecting real threats in ambiguous situations. But in the modern world, it can transform natural phenomena into evidence of conspiracy. The pattern repeated itself in 1938 with Orson Welles' War of the Worlds radio broadcast. While the actual panic was smaller than legend suggests, the event demonstrated how realistic media could blur the line between fiction and reality, especially when delivered through trusted channels during anxious times. People who tuned in mid-program heard what sounded like authentic news reports of Martian invasion. The format was familiar, the voices authoritative, the details convincing, only the content was fabricated. Today's sky offers both more authentic wonders and more sophisticated illusions than ever before. We can watch the International Space Station cross overhead with predictable precision, track satellite constellations as they deploy across the heavens, and witness rocket launches that paint temporary auroras against the upper atmosphere. But we can also watch synchronized drone swarms create temporary sculptures of light, laser shows that paint images on clouds, and computer-generated imagery so convincing that it requires expert analysis to detect. The technology for aerial spectacles has advanced exponentially. Intel's record-setting drone display used 1,218 individual craft, each equipped with LED lights and GPS guidance, coordinated by computer systems that calculated every movement to the millisecond. The result was a three-dimensional billboard in the sky, capable of displaying corporate logos, national flags, or abstract art with stunning precision. Such displays have become routine for major events worldwide, from Olympic ceremonies to product launches. But there's an enormous difference between coordinated drone shows, which everyone acknowledges as artificial, and the kind of atmospheric holography that Project Bluebeam theory requires. Real holographic displays work by manipulating light to create three-dimensional images, but they need specific mediums to interact with photons. Laboratory demonstrations can levitate small objects using acoustic or optical forces, creating impressive but tiny floating displays. Scaling such technology to continental proportions would require energy sources and coordination systems that exist only in science fiction. Our brains, meanwhile, remain stubbornly analog in their pattern recognition processes. Pareidolia, the tendency to perceive familiar shapes in random stimuli, makes us see faces in clouds, figures in shadows, and meaningful formations in arbitrary arrangements of lights. This neurological quirk served our ancestors well when distinguishing between rustling bushes and prowling predators. In the modern world, it makes every unusual sky phenomenon potentially significant. Social media has weaponized these cognitive biases. Algorithms reward engagement over accuracy, promoting content that generates strong emotional responses regardless of factual basis. A blurry video of moving lights can accumulate millions of views and thousands of shares before anyone bothers to verify whether it shows aircraft, drones, or computer graphics. The most spectacular clips often turn out to be the least authentic, but they travel fastest through networks primed for wonder and suspicion. The result is a modern information ecosystem where authentic astronomical events compete for attention with sophisticated hoaxes, marketing stunts, and misidentified conventional phenomena. A real comet developing its tail might generate fewer clicks than a fake video of mysterious lights arranged in impossible formations. Truth becomes a disadvantage in the attention economy. This creates a peculiar challenge for astronomers and science communicators. How do you convince people that a genuine interstellar visitor is more remarkable than any conspiracy theory? How do you compete with narratives that promise hidden knowledge, secret technologies, and grand deceptions when your story involves orbital mechanics, spectroscopy, and peer review? The answer lies partly in understanding what makes conspiracy theories appealing in the first place. They offer narrative coherence in a chaotic world, clear villains in complex situations, and special knowledge that elevates believers above the supposedly deceived masses. They transform random events into meaningful patterns, accidents into intentions, and observers into protagonists in cosmic dramas. But here's what conspiracy theories can't offer: the genuine awe that comes from understanding how the universe actually works. No human deception could match the reality of an interstellar object carrying samples of alien ice across impossible distances and unimaginable time. No projection technology could duplicate the precision of gravitational mechanics that bring visitors from distant star systems into our telescopic range at exactly the right moment for detailed study. The sky remains humanity's greatest screen, but we've learned to distinguish between the movies we project onto it and the genuine dramas that unfold there naturally. We can appreciate drone shows as human artistry while recognizing that comets represent something far more profound, messages from the universe itself, written in chemistry and physics, delivered across galactic distances to expand our understanding of existence. When we see unusual lights in the sky, we can ask better questions. Who measured this? What instruments were used? Can the observations be reproduced by independent teams? Are the data publicly available for scrutiny? These simple filters separate genuine discoveries from manufactured mysteries, real science from performance art. The most sophisticated conspiracy theories often contain grains of truth that make them persuasive. Yes, we can create impressive illusions in the sky. Yes, governments have conducted secret programs and psychological operations. Yes, technology exists to manipulate images, sounds, and even some aspects of human perception. But acknowledging these realities doesn't require accepting that every unusual phenomenon must be artificially produced. As 3I-ATLAS continues its journey through our inner solar system, it offers us a choice between two very different ways of experiencing wonder. We can see it as evidence of deception, part of an elaborate scheme to manipulate human consciousness through manufactured spectacles. Or we can see it as what it actually appears to be, a genuine ambassador from the cosmic wilderness, carrying chemical signatures from processes that shaped alien worlds billions of years ago. The choice reveals more about us than about the comet. In an age of infinite information and finite attention, we must decide whether to trust instruments or instincts, measurements or myths, evidence or intuition. The sky offers both authentic marvels and artificial entertainments, but only one category can teach us something true about the universe we inhabit. Part 5. When Stories Converge, a Rare Comet in a Conspiracy Decade. Timing, they say, is everything in comedy, tragedy, and apparently cosmic conspiracy theories. 3I-ATLAS couldn't have chosen a more provocative moment to arrive in our inner solar system. Here we are in the middle of 2025, living through what historians might someday call the Great Conspiracy Decade, when trust in institutions has eroded while access to information has exploded, creating perfect conditions for alternative narratives to flourish alongside legitimate science. The convergence isn't subtle. A genuinely rare interstellar visitor appears just as public discourse about unidentified aerial phenomena reaches fever pitch. Military officials acknowledge unexplained objects in restricted airspace. Government reports admit they can't explain everything they've detected. Social media algorithms amplify every ambiguous video until the signal-to-noise ratio approaches zero. Into this environment drops a comet from another star system, growing a magnificent tail just as internet culture has become primed to see deception in every spectacular sky event. Mainstream science coverage tells one story with admirable consistency. The Associated Press reports on the comet's growing tail, emphasizing safe distances and routine astronomical monitoring. The BBC covers new telescopic images with appropriate scientific caveats. Neue Lab releases time-lapse sequences showing natural evolution of the coma and tail structure. NASA maintains detailed web pages with orbital projections, safety assessments, and links to peer-reviewed research. The story they tell is methodical, measured, and frankly a bit boring. Interstellar object behaves like expected, poses no threat, offers interesting science opportunities. But parallel information ecosystems tell radically different stories. Speculative outlets highlight unusual chemical signatures as potentially artificial. Social media threads dissect every image for signs of geometric patterns or non-random structures. Comment sections fill with references to mini-probes and surveillance craft and blue beam activation protocols. The same photons captured by the same telescopes tell completely different stories depending on who's interpreting them. The split has created fascinating case studies in how modern information networks handle genuinely ambiguous events. When the James Webb Space Telescope published spectra showing unusual carbon dioxide ratios in the comet's outgassing, mainstream outlets focused on the implications for understanding interstellar ice formation. Alternative outlets wondered whether such unusual chemistry might indicate artificial composition or technological intervention. Both responses engaged with the same data, they just asked different questions about what it might mean. Consider how quickly legitimate scientific puzzles become fodder for conspiracy speculation. Early polarimetry measurements suggested extreme negative polarization behavior in 3I-ATLAS, technical language that describes how light scatters off dust particles in the comet's coma. For planetary scientists, this represents an opportunity to understand grain size, composition, and texture through sophisticated optical analysis. For conspiracy theorists, extreme and unusual become evidence of artificial construction or technological camouflage. The problem isn't that people are asking questions. Scientists love questions, even uncomfortable ones. The problem is that different communities have developed different standards for what constitutes acceptable answers. Peer-reviewed research requires reproducible methods, statistical analysis, and review by experts who actively try to find flaws in reasoning. Internet speculation requires only plausible-sounding explanations that confirm existing beliefs. This creates a peculiar dynamic where genuine scientific uncertainty gets weaponized by alternative narratives. When astronomers acknowledge that they don't yet understand 3I-ATLAS completely, its exact size, internal structure, rotation state, and long-term evolution remain topics of active research. Some interpretations transform that honesty into evidence of deception or cover-up. Scientific humility becomes suspicious evasion. Meanwhile, some researchers have contributed to the confusion by making dramatic claims without adequate peer review. When preprint servers publish speculative papers about possibly hostile, interstellar objects or alien technology probes, those ideas get amplified through media cycles before other scientists can respond with appropriate skepticism. The result is a landscape where peer-reviewed caution competes with sensationalistic speculation for public attention, and speculation often wins. The media environment rewards novelty over accuracy, generating perverse incentives for both scientists and journalists to oversell preliminary findings. A measured paper about unusual dust properties gets less attention than a speculative essay about potential alien visitors. Press releases emphasizing first-of-its-kind measurements draw more clicks than those discussing routine monitoring activities. The most responsible science communication, careful, conditional, hedged with appropriate uncertainty, struggles to compete with confident assertions and dramatic possibilities. Social media algorithms amplify these distortions exponentially. Platforms optimize for engagement, not enlightenment, promoting content that generates strong emotional responses regardless of factual basis. Videos claiming to show blue beam activation or comet probe deployment can accumulate millions of views before fact-checkers even notice they exist. By the time corrections circulate, the original misinformation has already shaped public perception and spawned countless derivative theories. The result is a modern information landscape where legitimate scientific discoveries get filtered through multiple interpretive frameworks simultaneously. 3I-ATLAS exists as both a natural interstellar comet studied by professional astronomers and a potential artificial construct monitored by conspiracy researchers. These parallel realities rarely interact directly, instead developing their own internal logic and supporting evidence. But here's what makes this moment historically significant. We're witnessing the first major interstellar visitor discovery in the age of social media conspiracy culture. Oumuamua arrived in 2017 when alternative narratives were less organized and less amplified. Borisov in 2019 looked so conventionally comet-like that it generated less speculative interest. 3I-ATLAS represents our first opportunity to observe how genuine cosmic discoveries get processed by information systems designed to amplify controversy and reward sensationalism. The stakes extend beyond astronomy. How societies distinguish between authentic discoveries and manufactured controversies will determine our capacity for collective learning and decision-making on issues from climate science to public health to technological policy. If every unusual finding gets filtered through conspiracy frameworks, we lose the ability to update our understanding based on new evidence. Yet the situation isn't entirely bleak. The same digital networks that spread misinformation also enable unprecedented access to primary scientific sources. Anyone with internet access can read the actual papers, examine the raw data, and follow the methodological discussions that shape scientific consensus. Social media platforms are experimenting with fact-checking systems, authoritative source labeling, and algorithmic adjustments designed to promote reliable information. The challenge lies in developing better collective immunity to manufactured controversies while maintaining healthy skepticism about institutional claims. We need to distinguish between productive questions that advance understanding and destructive speculation that undermines the possibility of shared knowledge. The difference often lies in methodology rather than conclusion. Good questions suggest ways to test competing hypotheses, while conspiracy theories resist falsification. As 3I-ATLAS continues its journey toward perihelion and beyond, it offers us an opportunity to practice these skills in relatively low-stakes circumstances. Unlike climate change or pandemic response, comet conspiracies don't directly threaten public health or global stability. We can afford to examine different interpretive frameworks, compare their explanatory power, and develop better heuristics for distinguishing signal from noise. The comet itself remains gloriously indifferent to human interpretation. It will continue sublimating carbon dioxide and water as solar heating intensifies. It will develop a longer tail as radiation pressure pushes dust particles away from the nucleus. It will follow precisely the hyperbolic trajectory that gravitational mechanics demands. The universe doesn't care whether we see natural processes or artificial deception. It just continues operating according to physical laws that don't negotiate with human preferences or beliefs. But we care, and should, because how we process this convergence of genuine wonder and manufactured mystery will shape our relationship with discovery itself. In a decade when conspiracy theories and scientific breakthroughs compete for the same cognitive real estate, 3I-ATLAS becomes more than just an interstellar visitor. It becomes a test of our collective ability to distinguish between what we want to be true and what actually is true. Part 6. Comets that came before. Oumuamua and 2I, Borisov. Before 3I-ATLAS, there were two other cosmic messengers that taught us how unprepared we were for visitors from beyond our solar system. Each arrival rewrote the textbooks, challenged our assumptions, and demonstrated that the universe holds more surprises than our theories anticipated. Understanding their stories illuminates both the promise and the peril of interpreting genuinely alien objects with human instruments and imagination. Oumuamua, Hawaiian for scout or messenger, announced itself on October 19, 2017, as a streak of reflected sunlight moving against the star field. The Pan-STARRS telescope in Hawaii caught it during its closest approach to the Sun, after it had already begun its journey back toward interstellar space. By the time astronomers realized they were looking at something extraordinary, the object was already racing away from us at over 87,000 miles per hour. What made Oumuamua immediately puzzling wasn't just its hyperbolic trajectory, that merely confirmed its interstellar origin. The real mystery lay in its behavior. As telescopes tracked its departure, they detected a subtle but persistent non-gravitational acceleration, as if something was gently pushing the object away from the Sun beyond what solar gravity alone could explain. For comets, such acceleration is routine. Solar heating vaporizes ices from the nucleus, creating jets of gas that act like tiny rocket engines, nudging the object off its purely gravitational path. But Oumuamua showed no obvious signs of outgassing, no visible coma, no detectable tail, no spectroscopic signatures of water vapor or other volatiles that should accompany active sublimation. The shape estimates made things even stranger. Extreme variations in reflected sunlight suggested an object roughly 800 feet long but only 80 feet wide, a cosmic cigar or pancake tumbling end over end with an 11-hour rotation period. No known asteroid or comet in our solar system displayed such radical dimensions. Either Oumuamua was naturally bizarre or artificially constructed. That ambiguity opened interpretive space for Harvard astronomer R.V. Loeb to suggest that Oumuamua might represent alien technology, specifically a light sail pushed by radiation pressure rather than conventional rocket propulsion. His hypothesis, while remaining a minority position among astronomers, generated enormous public interest and scientific debate. Here was a respected researcher at a prestigious institution arguing that our first confirmed interstellar visitor might be artificial. The controversy revealed how quickly legitimate scientific puzzles can morph into existential questions about our place in the universe. Oumuamua's unusual properties demanded explanation, but the available data supported multiple competing hypotheses. Natural explanations included outgassing from exotic ices, unusual internal structure, or fragmentation events that altered its shape. Artificial explanations ranged from derelict spacecraft to active probes conducting reconnaissance missions. Time was the enemy of resolution. Oumuamua was already departing when we discovered it, fading beyond telescopic reach before detailed follow-up studies could resolve the ambiguities. By early 2018, it had become too faint for even the largest ground-based telescopes to track. We were left with tantalizing glimpses and unanswered questions, a cosmic tease that demonstrated the importance of rapid response capabilities for future interstellar discoveries. 3I-Borisov arrived in August 2019 like a conventional comet from central casting, almost as if the universe wanted to reassure us that interstellar visitors could be comprehensible after all. Discovered by amateur astronomer Gennady Borisov using a homemade telescope in Crimea, the object immediately displayed the classic signatures of cometary activity, a fuzzy coma and developing tail that announced its icy composition to anyone with basic equipment. Unlike Oumuamua's mysterious acceleration, Borisov's behavior matched textbook predictions for how comets should respond to solar heating. Spectroscopic analysis detected water vapor, carbon monoxide, and other expected volatiles. The nucleus appeared to be a few kilometers across, large enough to sustain outgassing over extended periods. Even its color matched that of solar system comets formed in cold, distant regions. But Borisov carried its own surprises, revealing the chemical diversity possible in alien star systems. Detailed analysis showed unusual ratios of carbon monoxide to water compared to most local comets, suggesting formation under different temperature and radiation conditions than those that prevailed in our early solar nebula. The dust-to-gas ratio also differed from typical solar system values, indicating distinct evolutionary processes. More dramatically, Hubble Space Telescope observations in late 2019 detected what appeared to be fragmentation, the nucleus splitting into at least two pieces as tidal forces and thermal stress overwhelmed its structural integrity. This breakup provided unprecedented opportunities to study the internal composition of an interstellar object, revealing layered structure and heterogeneous materials that told stories about conditions in the comet's birth system. The contrast between our two previous interstellar visitors established important baselines for interpreting 3I-ATLAS. Oumuamua taught us that alien objects could challenge our theoretical frameworks and resist easy categorization. Borisov demonstrated that interstellar visitors could also conform to familiar patterns while still offering unique insights into cosmic processes. Both discoveries highlighted the importance of rapid, coordinated observation campaigns. Interstellar objects travel fast and fade quickly, offering limited windows for detailed study. The astronomical community learned to trigger alert networks, mobilize major telescopes, and coordinate international efforts within days rather than weeks of discovery announcements. They also revealed how public fascination with alien visitors could amplify scientific debates beyond professional channels. Oumuamua's ambiguous nature generated widespread speculation about extraterrestrial technology, forcing astronomers to engage with media and public interpretations while simultaneously conducting peer review processes. Borisov's more conventional behavior generated less speculative interest, but demonstrated that even normal interstellar comets could teach us profound lessons about planetary system formation. The speed factor cannot be overstated. Borisov approached the inner solar system at roughly 110,000 miles per hour, nearly 50 kilometers per second relative to the Sunday. At such velocities, objects traverse the observable region around our star in months rather than years, demanding rapid decisions about which instruments to deploy and what questions to prioritize. These time constraints create natural selection pressure, favoring bold hypotheses over cautious analysis. When you have only weeks to study an object that won't return for millions of years, the temptation to make dramatic claims based on preliminary data becomes almost irresistible. The peer review process, designed to filter out premature conclusions, struggles to keep pace with discovery timelines. Both previous visitors also demonstrated the value of amateur contributions to professional astronomy. Borisov was discovered by a dedicated hobbyist using equipment costing less than most automobiles. Amateur observers worldwide contributed tracking data, photometry, and imaging that supported professional research campaigns. The democratization of astronomical tools means that the next interstellar discovery might come from anyone with clear skies and sufficient dedication. Perhaps most importantly, Oumuamua and Borisov prepared us psychologically for 3I-ATLAS by establishing that interstellar visitors exist, arrive unpredictably, and display properties that can challenge our understanding while remaining within the bounds of natural explanation. They taught humility about the limits of remote sensing, while demonstrating the power of coordinated international science. The lesson for 3I-ATLAS seems clear: expect surprises, but start with comet physics. Unusual properties demand careful analysis rather than immediate exotic explanations. And remember that the universe has been conducting experiments in planetary formation for 13.8 billion years, creating chemical and physical conditions we've barely begun to catalogue. As we turn our attention to the current visitor, we carry forward the methodological insights gained from its predecessors. Better instruments, faster communication, and improved coordination protocols mean that 3I-ATLAS will receive more thorough study than either Oumuamua or Borisov. But the fundamental challenge remains the same: distinguishing between genuine anomalies that expand our knowledge and measurement uncertainties that merely expand our confusion. Part 7. The discovery of 3I-ATLAS. The discovery of 3I-ATLAS reads like a textbook case of how modern astronomy transforms cosmic accidents into scientific opportunities. On July 1, 2025, the ATLAS survey telescope at Rio Hurtado Observatory in Chile's Atacama Desert was conducting its routine patrol, hunting for potentially hazardous asteroids. The automated detection system flagged an unusual object moving against the star field, just another dot of light-shifting position between successive images. But this particular dot carried mathematical signatures that made it extraordinary. Within 24 hours, follow-up observations from multiple telescopes confirmed what preliminary orbital calculations suggested. This wasn't another resident of our solar system following a predictable elliptical path around the Sunday. The object's trajectory traced a hyperbolic curve, the mathematical signature of something that came from elsewhere and would return to elsewhere, unbound by our star's gravitational embrace. July 2 brought official recognition from the Minor Planet Center. The object received dual designations. 3I-ATLAS acknowledges its interstellar nature as the third such confirmed visitor, while C. 2025 non-identifies it as a comet discovered in the first half of 2025. That dual identity, interstellar object and active comet, immediately distinguished 3I-ATLAS from its predecessors. Oumuamua showed little obvious cometary activity despite its puzzling acceleration. Borisov behaved like a conventional comet but took months to develop obvious outgassing signatures. 3I-ATLAS began showing signs of activity almost immediately, developing a detectable coma within weeks of discovery and brightening rapidly as solar heating awakened its icy nucleus. The hyperbolic trajectory isn't just a mathematical curiosity. It's a story told in physics about incredible journeys across unimaginable distances. 3I-ATLAS is traveling at roughly 40 kilometers per second relative to the Sun, fast enough to cross the distance from Earth to Moon in less than 3 hours. Such velocities eliminate any possibility that this object originated within our solar system. Only gravitational interactions in dense stellar environments or catastrophic events like supernova explosions can impart the kinetic energy necessary for interstellar travel. Key dates promise both opportunities and frustrations for detailed study. Perihelion, the closest approach to our Sun, will occur around October 29-30, 2025, at approximately 1:36 to 1:4 astronomical units. During peak heating around perihelion, 3I-ATLAS will be positioned on the far side of the Sun as viewed from Earth, largely hidden behind solar glare just when its activity should reach maximum intensity. December 2025 brings compensation for this frustration, when the comet will make its closest approach to Earth at approximately 1:8 astronomical units, roughly 270 million kilometers away. Part 8. The Awakening, Sunlight, Coma, and Tail. There's something almost biological about how a comet awakens under the Sun's influence, transforming from a cold, dead chunk of space debris into a dynamic system that blazes across the sky with otherworldly beauty. 3I-ATLAS has been performing this ancient dance since late summer 2025, offering astronomers front-row seats to one of the most fundamental processes in our solar system. For millions of years, 3I-ATLAS drifted through the frigid vacuum between stars, its surface temperatures hovering just a few degrees above absolute zero. Every molecule of water, carbon dioxide and carbon monoxide locked in crystalline ice structures, preserved like prehistoric specimens in cosmic amber. But as our Sun's gravitational influence began tugging the comet toward the inner solar system, that ancient cold started yielding to something far more energetic. Cometary awakening follows predictable stages that astronomers can model with remarkable precision. The Gemini South Observatory in Chile has been documenting this awakening with high-resolution imaging. Late August, images showed the first obvious signs of coma development, a fuzzy envelope of gas and dust surrounding the nucleus. By early September, that coma had grown dramatically, fed by increasing sublimation rates as solar heating intensified. The tail development tells the most spectacular part of the story. As sublimating gases carry dust particles away from the nucleus, solar radiation pressure acts like an invisible wind, pushing the finest materials into elongated streams that can stretch millions of kilometers through space. The geometry creates both opportunities and frustrations for Earth-based observers. During the October perihelion passage, when tail development should achieve peak magnificence, 3I-ATLAS will be positioned on the far side of the Sun from Earth's perspective. The Mars flyby on October 3 adds another dimension to the awakening story. 3I-ATLAS will pass within approximately 28 million kilometers of the Red Planet, close enough to potentially attempt observations from Mars-orbiting spacecraft, though such efforts would be technically challenging. The awakening process provides natural experiments in comparative planetology. 3I-ATLAS formed in an alien star system under different conditions than those that shaped comets in our solar neighborhood. As solar heating drives off its surface materials, we're essentially conducting forensic analysis of exoplanetary chemistry, learning about processes that occurred billions of years ago in star systems we may never visit directly. Part 9. Inside the Comet. What telescopes are finding? Peer inside 3I-ATLAS with the galaxy's most sophisticated instruments, and you'll discover chemistry that tells stories about star formation and cosmic evolution. The The James Webb Space Telescope turned its infrared eyes toward the comet on August 6, 2025, capturing spectra that read like chemical fingerprints from an alien world, familiar elements arranged in unfamiliar proportions. The headline discovery centers on carbon dioxide dominance that defies conventional comet chemistry. Most comets in our solar system show water as the primary volatile component, with carbon dioxide playing a supporting role. But 3I-ATLAS flips that script dramatically, displaying a carbon dioxide to water ratio of approximately 8:1, a chemical signature that suggests formation under radically different conditions than those that prevailed in our early solar nebula. This isn't just an academic curiosity about ratios. The carbon dioxide dominance provides direct evidence about temperature and pressure conditions in the alien star system where 3I-ATLAS formed billions of years ago. Carbon dioxide freezes at higher temperatures than water in typical nebular conditions, creating distinct frost lines around young stars where different volatile compounds condense into solid grains. The James Webb data reveals additional chemical complexity. Beyond carbon dioxide and water signatures, spectroscopic analysis has identified carbon monoxide, carbonyl sulfide, water ice, and various dust components. Each detection represents a triumph of remote sensing technology, revealing molecular signatures from samples that traveled dozens of light years to reach our instruments. Complementary observations from the Swift Space Telescope detected hydroxyl emission, a chemical signature of water molecules being broken apart by solar ultraviolet radiation, at distances exceeding 3 astronomical units from the sunday. This confirms substantial water activity earlier and farther from perihelion than typical for solar system comets. What we don't yet know reveals the limitations of remote sensing even with our finest instruments. The exact size and shape of the nucleus remain uncertain because the bright coma obscures direct observation of the underlying solid body. Current estimates suggest a diameter somewhere between 1 and 10 kilometers. Comparative analysis with 2I, Borisov reveals both similarities and crucial differences. Borisov showed more conventional water-dominated composition with carbon monoxide ratios closer to solar system norms. The contrast suggests that 3I-ATLAS samples a different population of interstellar objects, possibly formed under distinct conditions. Part 10. Harmless yet haunting: what the orbit really says. Mathematics doesn't lie, and the mathematics of 3I-ATLAS tell a story of precise trajectories, vast distances, and absolutely zero threat to anyone or anything in our solar system. The minimum distance to Earth tells the essential story, approximately 1.8 astronomical units in December 2025, which translates to roughly 270 million kilometers, or about 700 times the distance from Earth to Moon. Perihelion distance provides additional context. At closest approach to the Sun around October 29-30, 3I-ATLAS will reach approximately 1.36 to 1.4 astronomical units inside Mars's orbit, but well outside Earth's. This intermediate distance explains the comet's awakening timeline without requiring mysterious explanations. Solar heating follows inverse square law relationships that astronomers can calculate with precision. Speed provides dramatic evidence for natural rather than artificial origin. 3I-ATLAS approaches our solar system at roughly 40 kilometers per second relative to the Sun, fast enough to outrun any conceivable human propulsion technology. Such velocities arise naturally from gravitational interactions in dense stellar environments. The hyperbolic trajectory itself eliminates any possibility of capture or collision. Unlike elliptical orbits that bring periodic comets back for return visits, hyperbolic paths represent one-way journeys through our neighborhood. 3I-ATLAS arrived from interstellar space and will return to interstellar space, following gravitational mechanics as predictable as sunrise and sunset. Orbital determination relies on hundreds of precise measurements from observatories worldwide, creating redundant conformations that eliminate systematic errors. the Minor Planet Center coordinates these observations and publishes updated orbital elements. NASA's Jet Propulsion Laboratory maintains independent calculations that cross-check the international results. The visibility timeline reveals orbital reality that some struggle to accommodate. Near perihelion, when 3I-ATLAS reaches peak activity, it will be positioned almost directly behind the Sun as viewed from Earth. This geometry hides the comet during its most spectacular phase, creating exactly the kind of timing that might seem suspicious. But celestial mechanics doesn't negotiate with human convenience. Comet orbits predate human civilization by billions of years. The trajectory calculations reveal interesting details about 3I-ATLAS origin and destination. Backward integration suggests the comet approached from the direction of the constellation Lynx. Forward integration shows it will depart toward the constellation Sextans, carrying samples of our Sun's radiation environment back toward the galactic disk. These directional details reflect the comet's random walk through galactic gravitational fields over millions of years. Professional astronomers express none of the anxiety that pervades online speculation. NASA maintains detailed frequently asked questions pages explaining the comet's trajectory and safety margins. The unanimous consensus among people who actually calculate orbits for a living remains clear: interesting science opportunity, zero threat potential. The real haunting aspect of 3I-ATLAS isn't physical danger, it's existential contemplation. Here's an object that formed around another star, possibly before Earth even existed, that has wandered the galaxy for unimaginable ages before arriving at precisely the moment when human technology can study its secrets. The mathematics of that convergence staggers the imagination more than any conspiracy theory could. Perhaps that's why some minds reach for artificial explanations. The universe's genuine mysteries, the odds against interstellar visitors arriving during humanity's brief technological adolescence, the chemistry that reveals alien star formation processes, the physics that connects our local solar system to galactic evolution, require confronting scales of space and time that humble human significance. But orbital mechanics remains beautifully indifferent to human psychology. 3I-ATLAS will continue following its hyperbolic path regardless of our interpretation. The numbers don't change based on our beliefs, fears, or hopes. The comet's trajectory represents one of the most precisely determined paths in astronomy, confirmed by hundreds of observations from dozens of telescopes across multiple continents. Sometimes the most haunting truth is the simplest one. We live in a universe far stranger and more magnificent than any conspiracy theory could imagine. Part 11. The Blue Beam Connection. How 3I-ATLAS gets woven in. Watch how a genuine astronomical discovery gets transformed into conspiracy fodder, and you'll witness one of the most fascinating dynamics of our digital age. The process by which legitimate science becomes raw material for alternative narratives that spread faster than fact-checkers can respond. 3I-ATLAS offers a perfect case study in this phenomenon, arriving at precisely the moment when online culture has become primed to see deception in every spectacular sky event. The connection begins with timing that conspiracy theorists find suspiciously convenient. Here's a genuinely rare interstellar visitor developing a magnificent tale just as public discourse about unidentified aerial phenomena reaches fever pitch. Social media algorithms, designed to maximize engagement rather than accuracy, inevitably amplify posts that link unusual celestial events to broader patterns of supposed government deception. Search Twitter, Facebook, or TikTok for 3I-ATLAS, and you'll find posts mixing legitimate astronomical information with speculation about Project Blue Beam activation protocols and interstellar surveillance platforms. The same telescopic images released by Noilab and other professional observatories get recontextualized through conspiracy frameworks that interpret natural comet behavior as evidence of technological manipulation. The pattern follows predictable stages that social media researchers have documented across multiple conspiracy topics. First comes the legitimate news announcement, in this case, discovery of our third confirmed interstellar object by the ATLAS survey. Mainstream outlets like the Associated Press and BBC cover the story with appropriate scientific caveats about distance, safety, and ongoing research. But parallel information ecosystems immediately begin alternative interpretations. Within hours of the initial discovery announcement, online communities dedicated to conspiracy theories start analyzing the same images and data through radically different interpretive lenses. What astronomers describe as natural sublimation processes become controlled outgassing or propulsion system activation in these alternative frameworks. The reinterpretation accelerates as more spectacular images become available. Noilab's time-lapse sequences, showing tail development over several weeks, provide stunning documentation of natural comet evolution. But those same sequences, when divorced from scientific context and presented with speculative commentary, can appear to show geometric patterns, artificial structures, or coordinated light displays to viewers primed for deception. The blue beam connection gains traction through a process that researchers call pattern matching, the human tendency to connect disparate events through perceived similarities rather than causal relationships. 3I-ATLAS develops a growing tail at the same time that other unusual aerial phenomena generate headlines. Military acknowledgements of unexplained objects in restricted airspace. Drone swarms creating temporary art installations. Rocket launches painting auroras against the upper atmosphere. To minds seeking overarching explanations for complex events, these separate phenomena become connected components of a larger orchestrated program. Never mind that interstellar objects follow predictable orbital mechanics while drone shows require human coordination. Never mind that comet chemistry can be verified through spectroscopy while blue beam remains entirely theoretical. The pattern matching process overwhelms analytical thinking. Social media amplifies these connections exponentially. Algorithms designed to maximize user engagement naturally promote content that generates strong emotional responses: surprise, fear, anger, wonder, regardless of factual accuracy. A carefully researched astronomical paper about 3I-ATLAS composition might reach thousands of readers. A speculative video claiming to reveal blue beam comet secrets can accumulate millions of views within days. The speed of viral propagation creates particular challenges for scientific response. Peer-reviewed research operates on timescales of months or years, emphasizing careful analysis over rapid publication. Conspiracy theories operate on timescales of hours or days, prioritizing emotional impact over analytical rigor. By the time scientists can respond with appropriate skepticism and contrary evidence, alternative narratives have already shaped public perception and generated derivative theories. This temporal mismatch explains why some of the most spectacular conspiracy claims about 3I-ATLAS remain unanswered by official sources. It's not because astronomers lack responses, it's because the professional scientific community prioritizes accuracy over speed, peer review over publicity, and measured uncertainty over confident assertion. These values, essential for advancing knowledge, become disadvantages in information environments that reward bold claims over careful reasoning. The blue beam framework provides particularly fertile ground for 3I-ATLAS speculation because it offers a comprehensive explanatory system that can incorporate almost any unusual observation, unusual chemical composition, evidence of artificial construction, asymmetric outgassing, sign of propulsion systems, growing tail, manufactured spectacle for psychological manipulation. The theory becomes unfalsifiable by interpreting all evidence as confirmation of its central premises. Professional astronomers find themselves in an impossible position when addressing such claims. Detailed refutations risk amplifying conspiracy theories by dignifying them with extensive response. Ignoring them allows alternative narratives to spread unchallenged. Gentle correction often gets interpreted as evidence of cover-up or institutional complicity. The very expertise that qualifies scientists to evaluate astronomical claims also makes them suspects in conspiracy frameworks that assume institutional deception. Media literacy becomes crucial for navigating this landscape. Simple questions can separate legitimate astronomical findings from manufactured controversies. Who took the measurements? What instruments were used? Are the data publicly available for independent verification? Can multiple research groups reproduce the results? These filters reliably distinguish between genuine discoveries and speculative entertainment. But even well-intentioned media coverage can inadvertently fuel conspiracy theories through sensationalized headlines, dramatic imagery, and insufficient context about normal scientific uncertainty. When legitimate papers about unusual 3I-ATLAS properties get presented with headlines about mysterious alien chemistry or unprecedented behavior, they become raw material for alternative interpretations that the original researchers never intended. The phenomenon reveals deeper tensions between scientific methods and public communication in the digital age. Science thrives on uncertainty, debate, and gradual consensus building through peer review and replication. Public discourse increasingly rewards confidence, novelty, and immediate answers to complex questions. 3I-ATLAS exists at the intersection of these incompatible communication cultures. Perhaps most troubling is how blue beam speculation about 3I-ATLAS discourages genuine curiosity about authentic cosmic phenomena. When people become convinced that spectacular sky events might be artificially manufactured, they lose the capacity to appreciate real astronomical discoveries. The universe's most magnificent displays become indistinguishable from imagined deceptions. Yet the same digital networks that spread conspiracy theories also enable unprecedented access to primary scientific sources. Anyone with internet access can read the actual research papers, examine raw observational data, and follow methodological discussions that shape legitimate scientific consensus. Social media platforms are experimenting with fact-checking systems and authoritative source labeling designed to promote reliable information. The challenge lies in developing better collective immunity to manufactured controversies while maintaining healthy skepticism about institutional claims. We need heuristics for distinguishing between productive questions that advance understanding and destructive speculation that undermines shared knowledge. The difference often lies in methodology rather than conclusion. Good questions suggest testable hypotheses, while conspiracy theories resist falsification. As 3I-ATLAS continues its journey through our inner solar system, it offers ongoing opportunities to practice these skills in relatively low-stakes circumstances. Unlike climate science or public health policy, comet conspiracies don't directly threaten social welfare or global stability. We can afford to examine competing interpretive frameworks and develop better techniques for separating signal from noise. The real test isn't whether 3I-ATLAS represents natural phenomena or artificial construction. The overwhelming evidence supports natural explanation. The test is whether we can maintain both wonder and wisdom in an information environment designed to amplify emotion over analysis, speculation over science, and engagement over enlightenment. Part 12. Theories of probes and illusions. What people are saying. Dive into the speculative waters surrounding 3I-ATLAS, and you'll encounter claims that range from scientifically plausible to thoroughly fantastical, often presented with equal confidence and conviction. The challenge lies not in dismissing all speculation. Some hypotheses deserve serious consideration, but in distinguishing between ideas that advance understanding and those that merely multiply confusion. The mini-probes narrative represents perhaps the most persistent speculative thread weaving through 3I-ATLAS discussions. Proponents suggest that what appears to be a natural comet might actually be a carrier system deploying smaller reconnaissance craft as it traverses our solar system. These hypothetical probes would separate from the main body during perihelion approach, using the comet's outgassing as cover for insertion into various monitoring positions throughout our planetary neighborhood. Such claims remain entirely unverified and highly controversial within the astronomical community. No observational evidence supports the detection of discrete objects separating from 3I-ATLAS or exhibiting independent trajectories distinct from expected comet fragment behavior. High-resolution imaging from multiple observatories shows morphological evolution consistent with natural sublimation and dust ejection rather than mechanical deployment of artificial systems. The speculation gained additional traction through a recent preprint paper that assigned possibly hostile technology interpretations to various interstellar object observations. However, this document explicitly labels itself as a pedagogical exercise designed to explore how one might analyze potentially artificial visitors, not as a claim that such visitors actually exist. The distinction between thought experiment and evidence assessment has been lost in much subsequent media coverage and social media discussion. Academic researchers like Avi Loeb have contributed to the speculative atmosphere through opinion essays and media interviews that assign non-zero probability to extraterrestrial technology explanations for unusual interstellar object properties. While Loeb's speculation remains within bounds of scientific discourse, he proposes testable hypotheses rather than unfalsifiable conspiracy theories. His prominent institutional affiliations lend credibility to ideas that most astronomers consider premature or poorly supported by available evidence. The alien technology framework faces substantial evidential challenges when applied to 3I-ATLAS. The comet's behavior matches theoretical predictions for natural sublimation processes responding to solar heating. Its chemical composition, while unusual in carbon dioxide dominance, falls within ranges observed for solar system comets formed under different temperature conditions. Its trajectory follows precise gravitational mechanics without unexplained accelerations or course corrections that might suggest propulsion systems. Separating legitimate scientific speculation from pure fantasy requires careful attention to methodology and evidence standards. Responsible researchers acknowledge uncertainty while proposing specific observational tests that could distinguish between competing hypotheses. Irresponsible speculation makes dramatic claims based on ambiguous data while resisting attempts at falsification through additional observations. The blue beam illusion angle takes conspiracy speculation in a different direction entirely, suggesting that 3I-ATLAS might represent a sophisticated holographic projection designed to test public responses to apparent interstellar visitors. This framework assumes technological capabilities far beyond anything demonstrated in laboratory settings or operational deployments. Current projection technology can indeed create impressive aerial displays through synchronized drone swarms, laser light shows, and specialized atmospheric effects. Intel's record-setting drone formations, military laser weapon systems, and experimental plasma manipulation techniques provide genuine examples of human capability to create temporary spectacles in the sky. But scaling such technologies to create convincing interstellar object simulations would require capabilities that don't currently exist in any practical form. A hypothetical 3I-ATLAS illusion would need to fool multiple independent observatories using different detection methods: visible light imaging, infrared spectroscopy, radiotelescopy, and gravitational perturbation measurements. Coordinating such deception across dozens of research institutions in multiple countries would represent logistical challenges orders of magnitude beyond any demonstrated conspiracy capability. The holographic explanation also fails to account for the extended timeline of 3I-ATLAS observations. Real projection systems create temporary displays lasting hours or days. This supposed illusion has maintained consistency across months of detailed study, with morphological changes that follow predictable patterns based on orbital mechanics and solar heating models. Such long-term consistency would require energy sources and coordination systems that exist only in science fiction. More subtle concerns about institutional complicity sometimes surface in conspiracy discussions, suggesting that the entire astronomical establishment might be aware of 3I-ATLAS' artificial nature but complicit in maintaining deceptive narratives for undefined political purposes. Such reasoning creates intellectual quicksand that swallows counterarguments and grows stronger with attempted refutation. This unfalsifiable aspect makes institutional conspiracy theories particularly dangerous to scientific discourse. When any evidence against artificial explanations becomes reinterpreted as evidence for conspiracy sophistication, rational evaluation becomes impossible. The theory immunizes itself against correction through logical structures that prevent learning from new observations. Independent verification provides the strongest counter to institutional conspiracy claims. 3I-ATLAS has been observed by amateur astronomers using personal telescopes, university researchers with modest equipment, and professional observatories with billion-dollar instruments. The consistency of results across this diverse observational base makes coordinated deception virtually impossible to sustain. International cooperation adds another layer of verification complexity that conspiracy theories struggle to accommodate. Astronomers from the United States, Chile, Europe, Japan, and other nations have contributed observational data and analysis that all point toward natural comet explanations. Coordinating deception across such diverse political and institutional environments would require unprecedented levels of international conspiracy cooperation. The peer review process, while imperfect, provides additional safeguards against both inadvertent error and intentional deception. Multiple independent researchers examine methodology, check calculations, and attempt to reproduce results before accepting papers for publication. This system has caught numerous errors and prevented premature conclusions from entering scientific literature. However, the same peer review system that prevents bad science from being accepted also operates slowly enough that speculative claims can gain public traction before professional correction occurs. Preprint servers allow researchers to share preliminary results immediately, but without the quality control that formal peer review provides. Social media amplifies the most dramatic preliminary claims while often ignoring subsequent corrections or retractions. Media coverage adds another layer of complexity to separating legitimate scientific debate from unfounded speculation. Some outlets maintain clear distinctions between peer-reviewed findings and speculative commentary, while others blur these lines in pursuit of engagement and novelty. Headlines claiming, "Scientists believe aliens," often describe minority opinions or preliminary hypotheses rather than established consensus. The challenge for public understanding lies in developing better heuristics for evaluating competing claims about ambiguous phenomena. Simple questions can help. Are specific predictions made that could be tested through additional observations? Do the proposed explanations make unnecessary assumptions about unknown technologies or coordinated deception? Can multiple independent research groups reproduce the claimed results? Applied to 3I-ATLAS, these filters reliably separate evidence-based conclusions from speculative entertainment. Natural comet explanations make specific predictions about chemical evolution, tail development, and orbital mechanics that have been confirmed through extended observation campaigns. Artificial explanations require assumptions about technologies and coordination capabilities that remain entirely theoretical. Perhaps most importantly, the speculation surrounding 3I-ATLAS reveals how genuine scientific uncertainty gets exploited by alternative narratives that promise more definitive answers than evidence actually supports. The universe presents us with phenomena that challenge understanding and require patient investigation to decode properly. Conspiracy theories offer immediate explanations that satisfy psychological needs for comprehension and control, even when those explanations lack factual foundation. The distinction matters because how we evaluate genuinely ambiguous phenomena determines our capacity for collective learning and rational decision-making on issues that affect human welfare. If every unusual finding gets filtered through conspiracy frameworks that resist correction through additional evidence, we lose the ability to update our understanding based on new information. Part 13. Science Responds. What the measurements actually show. Strip away speculation, ignore the social media noise, and focus solely on what instruments actually detect when pointed at 3I-ATLAS. What emerges is a coherent picture of natural phenomena, operating according to well-understood physical principles. Even when those phenomena display unusual characteristics that expand our knowledge of interstellar chemistry and comet evolution. The James Webb Space Telescope's infrared spectroscopy from August 6, 2025, provides the most detailed chemical fingerprinting available for any interstellar object to date. The carbon dioxide dominance, roughly 8 times more abundant than water vapor, represents genuine novelty in cometary composition, but falls well within bounds of natural explanation. Similar ratios have been observed in some solar system comets formed in cold, distant regions where carbon dioxide ice condensation dominated over water ice formation. The detection methodology itself demonstrates the power and precision of modern astronomical instrumentation. Webb's NIRSPEC instrument identified specific molecular signatures through characteristic absorption and emission lines that cannot be faked or misinterpreted. Carbon dioxide, water, carbon monoxide, carbonyl sulfide, water ice, and dust components each produce unique spectroscopic fingerprints that require specific physical conditions to generate. Independent confirmation comes from complementary observations using different instruments and detection methods. Swift Observatory's ultraviolet observations detected hydroxyl emission, the breakdown product of water molecules exposed to solar radiation, at distances exceeding 3 astronomical units from the Sunday. This detection confirms substantial water activity using completely different physics and instrumentation than the James Webb infrared measurements. The spatial distribution of detected emissions provides additional evidence for natural processes rather than artificial construction. Enhanced outgassing toward the sun-facing hemisphere creates asymmetric coma structure consistent with solar heating models. If 3I-ATLAS represented some form of technological construct, such asymmetry would require sophisticated thermal management systems operating according to the same principles that govern natural comet behavior. Morphological evolution documented through high-resolution imaging tells a consistent story of gradual awakening as solar heating intensifies. NOILAB's Gemini South Telescope has tracked tail development and coma expansion over multiple weeks, creating time-lapse sequences that show smooth evolution rather than sudden changes that might indicate artificial activation or technological intervention. The orbital solution itself provides robust evidence for natural gravitational mechanics. Hundreds of precise astrometric measurements from observatories worldwide have been combined to determine the hyperbolic trajectory with extraordinary precision. Any artificial propulsion system would need to operate with such subtlety that it mimics natural gravitational motion within measurement uncertainties, a level of technological sophistication that would be remarkable even if such systems existed. Polarimetry measurements, while revealing unusual dust properties, remain consistent with natural grain formation and evolution processes. The extreme negative polarization behavior observed at small phase angles provides valuable diagnostic information about particle size distributions and surface textures, but doesn't require exotic explanations involving artificial materials or technological camouflage systems. Professional astronomical consensus reflects the weight of accumulated evidence rather than institutional groupthink or coordinated deception. Independent research teams using different instruments and analysis methods have reached similar conclusions about 3I-ATLAS composition, behavior, and trajectory. Such convergence occurs routinely in legitimate scientific research, but would be virtually impossible to coordinate across diverse international institutions if deception were involved. The peer review process, while still ongoing for some analyses, provides additional quality control that separates robust findings from preliminary speculation. The James Webb carbon dioxide detection appears in a manuscript submitted to Astrophysical Journal Letters, where it will undergo scrutiny by expert reviewers who actively seek methodological flaws and alternative interpretations. This process sometimes leads to revised conclusions, but it represents scientific strength rather than institutional weakness. Measurement uncertainties get reported transparently rather than hidden behind claims of absolute certainty. Current estimates of nucleus size, rotation period, and internal structure acknowledge substantial error bars that reflect the limitations of remote sensing across interstellar distances. Such honesty about uncertainty contrasts sharply with conspiracy theories that claim definitive knowledge based on ambiguous evidence. The timeline of observational campaigns demonstrates how scientific knowledge accumulates through patient data collection rather than dramatic revelation. Initial detection in July led to rapid follow-up observations in August, detailed spectroscopy in September, and ongoing monitoring campaigns that will continue through perihelion and beyond. Each observation refines previous measurements and occasionally reveals unexpected properties that require explanation. But unexpected doesn't mean inexplicable. The unusual carbon dioxide dominance surprised researchers familiar with typical solar system comet chemistry, but it fits within theoretical frameworks for how icy bodies might form under different stellar environments. Science advances precisely through such surprises that force expansion of existing models rather than abandonment of physical principles. International cooperation adds robustness to findings that would be difficult to achieve through any single research program. Teams from the United States, Chile, Europe, and other nations have contributed observational data and analysis using independent instruments and methods. The consistency of results across this diverse base provides strong evidence against coordinated deception or systematic error. Amateur contributions complement professional observations in ways that further validate scientific conclusions. Dedicated hobbyists using modest equipment have tracked 3I-ATLAS brightness variations, confirmed orbital predictions, and occasionally detected activity changes between scheduled professional observing sessions. Such grassroots participation makes large-scale deception virtually impossible to maintain. Real-time data availability distinguishes legitimate astronomical research from secretive government programs. Orbital elements get updated daily through the Minor Planet Center. Observational images are released through observatory websites within days or weeks of acquisition. Research papers appear on preprint servers before formal publication, allowing immediate scrutiny by the global scientific community. This transparency creates accountability mechanisms that prevent sustained scientific fraud or institutional cover-ups. Any researcher making false claims about 3I-ATLAS would face immediate correction by colleagues with access to the same data and analysis tools. The collaborative nature of modern astronomy makes deception self-defeating for career-minded scientists. The burden of proof remains firmly on those claiming artificial explanations for 3I-ATLAS behavior. Natural comet physics provides sufficient explanation for all observed properties without requiring additional assumptions about unknown technologies, coordinated conspiracies, or exotic physical processes. Extraordinary claims about alien probes or holographic illusions demand extraordinary evidence that simply doesn't exist in the accumulated observational record. Statistical analysis supports natural explanations through multiple independent lines of evidence. Chemical composition matches expectations for interstellar ices. Orbital mechanics follows gravitational theory. Morphological evolution conforms to sublimation models. Activity patterns correlate with solar heating cycles. The convergence of evidence across multiple physical processes makes artificial explanations increasingly implausible. Perhaps most importantly, the scientific response to 3I-ATLAS demonstrates how genuine research differs from conspiracy speculation in fundamental ways. Scientists make specific predictions that can be tested through additional observations. They acknowledge uncertainty and modify conclusions when new evidence warrants. They subject their work to peer review and welcome attempts at replication by independent researchers. Conspiracy theories, by contrast, resist falsification by interpreting all evidence as confirmation of predetermined conclusions. They assume coordination capabilities and technological sophistication that remain entirely theoretical. They rely on unfalsifiable claims about institutional deception that immunize themselves against correction through additional information. The measurements speak clearly to anyone willing to listen with appropriate scientific literacy. 3I-ATLAS represents a natural interstellar comet, displaying unusual but explicable chemistry as it responds to solar heating during its passage through our planetary system. No aliens required, no holograms necessary, no conspiracy coordination demanded, just patient application of scientific method to genuinely extraordinary natural phenomena that expand our understanding of cosmic processes. Part 14. Why we see signs in the sky. A human story. Look up at any night sky, and you're gazing through the same neural architecture that helped your ancestors survive ice ages, predator encounters, and rival tribes. Pattern recognition systems evolved for finding meaning in ambiguous stimuli, even when no meaning exists. This ancient cognitive machinery serves us well in many contexts, but it creates particular challenges when we encounter genuinely unusual phenomena like interstellar visitors in an age of sophisticated information manipulation. The historical precedent runs deep and instructive. When Halley's Comet returned in 1910, newspapers transformed a routine astronomical event into an existential crisis through sensationalized coverage of potential cyanogen poisoning from the comet's tail. Never mind that the tail's density barely exceeded interplanetary vacuum, fear propagated faster than facts, creating markets for comet pills and gas masks that entrepreneurs happily supplied to terrified customers. The 1910 panic reveals core features of human psychology that remain unchanged despite technological advancement. We project agency onto random events, especially when they're rare, visible, and poorly understood by the general public. A comet doesn't simply appear, it appears for a reason, carrying messages, presaging change, fulfilling ancient prophecies or modern conspiracies depending on the cultural context. This tendency toward apophenia, perceiving meaningful patterns in random information, represents an evolutionary adaptation that helped our ancestors detect genuine threats in ambiguous situations. Better to mistake rustling bushes for predators than ignore actual predators in rustling bushes. But in modern contexts, the same cognitive shortcuts that once provided survival advantages can transform natural phenomena into evidence of artificial manipulation. The 1938 War of the Worlds broadcast provided another lesson in how realistic media formats can blur the boundaries between fiction and reality, particularly during anxious historical moments. While actual panic was less widespread than popular legend suggests, the incident demonstrated how trusted communication channels could inadvertently create believable deceptions through format manipulation rather than content fabrication. Today's information environment combines these historical vulnerabilities with technological capabilities that would seem magical to previous generations. We can watch the International Space Station trace predictable paths overhead, track satellite constellations deploying across the heavens, and witness rocket launches painting temporary auroras against the upper atmosphere. But we can also watch synchronized drone swarms create temporary sculptures of light, laser shows projecting images onto clouds, and computer-generated imagery so convincing that expert analysis is required to detect manipulation. The technological duality creates perfect conditions for conspiracy theories that blend genuine capabilities with imagined extensions. Intel's world record drone display using over 1,000 synchronized aircraft provides concrete evidence that impressive aerial spectacles can be artificially created. Military laser systems and plasma manipulation experiments demonstrate that humans possess exotic technologies for atmospheric effects. These real capabilities make speculation about more advanced secret programs seem plausible rather than fantastical. But enormous gaps exist between demonstrated technologies and the capabilities that Project Bluebeam theories require. Coordinated drone shows remain limited in scale, duration, and visual complexity compared to the continental holographic projections that conspiracy theories envision. Laboratory plasma manipulation creates small-scale effects measured in centimeters rather than the atmospheric displays spanning thousands of kilometers that would be necessary for global deception programs. Social media algorithms exploit these cognitive vulnerabilities with precision that evolutionary psychologists could admire. Platforms optimize for engagement rather than enlightenment, promoting content that generates strong emotional responses: surprise, fear, anger, wonder, regardless of factual accuracy. A carefully researched paper about 3I-ATLAS chemistry might reach thousands of readers, while a speculative video claiming blue beam activation can accumulate millions of views within days. The speed differential between viral misinformation and careful correction creates asymmetric warfare between conspiracy theories and scientific response. Peer-reviewed research operates on timescales of months or years, emphasizing accuracy over immediacy. Speculative content operates on timescales of hours or days, prioritizing emotional impact over analytical rigor. By the time scientists can respond with appropriate evidence and methodology, alternative narratives have already captured public attention and spawned derivative theories. Pareidolia adds another layer of complexity to sky-based conspiracy theories. This neurological tendency to perceive familiar shapes in random stimuli, faces in clouds, figures in shadows, geometric patterns in arbitrary light arrangements, creates infinite raw material for alternative interpretations of astronomical phenomena. Every unusual formation of planets, stars, or atmospheric effects becomes potential evidence of artificial construction or deliberate messaging. The phenomenon explains why the same telescopic images of 3I-ATLAS can support radically different interpretations depending on the viewer's expectations and prior beliefs. Astronomers trained in comet physics see natural sublimation processes creating predictable tail structures. Conspiracy theorists primed for deception see geometric patterns, artificial lighting, or coordinated displays that suggest technological intervention. Modern media literacy becomes essential for navigating this landscape, but traditional education systems struggle to keep pace with evolving deception techniques and distribution methods. Simple heuristics can help separate legitimate scientific findings from manufactured controversies. Who made the measurements? What instruments were used? Are the data publicly available? Can independent research groups reproduce the results? But even well-intentioned attempts at scientific communication can inadvertently fuel conspiracy speculation through sensationalized headlines, dramatic imagery, and insufficient context about normal scientific uncertainty. When legitimate research about unusual 3I-ATLAS properties gets presented with headlines about mysterious alien chemistry or unprecedented behavior, it becomes raw material for alternative interpretations that the original researchers never intended. The challenge runs deeper than simple media manipulation. It reflects fundamental tensions between scientific methods and public communication in the digital age. Science thrives on uncertainty, debate, and gradual consensus building through peer review and replication. Public discourse increasingly rewards confidence, novelty, and immediate answers to complex questions. These incompatible communication cultures create fertile ground for conspiracy theories that promise certainty in uncertain domains. Trust in institutions plays a crucial role in determining whether people interpret unusual phenomena as natural mysteries deserving patient investigation or artificial deceptions requiring immediate resistance. When institutional credibility erodes, whether through legitimate policy failures, perceived elite capture, or systematic disinformation campaigns, alternative explanatory frameworks gain appeal regardless of their factual foundation. The psychological appeal of conspiracy theories extends beyond simple distrust to fundamental human needs for narrative coherence, personal significance, and special knowledge. Believing that 3I-ATLAS represents advanced alien technology or government deception makes observers protagonists in cosmic dramas rather than passive witnesses to random celestial mechanics. The conspiracy framework transforms cosmic insignificance into personal relevance. Yet the same digital networks that amplify conspiracy theories also enable unprecedented access to primary scientific sources. Anyone with internet access can read actual research papers, examine raw observational data, and follow methodological discussions that shape legitimate scientific consensus. Social media platforms experiment with fact-checking systems, authoritative source labeling, and algorithmic modifications designed to promote reliable information over engaging misinformation. The key lies in developing better collective immunity to manufactured controversies while maintaining healthy skepticism about institutional claims. We need heuristics for distinguishing between productive questions that advance understanding and destructive speculation that undermines the possibility of shared knowledge. The difference often lies in methodology rather than conclusion. Good questions suggest testable hypotheses, while conspiracy theories resist falsification through additional evidence. As 3I-ATLAS continues its journey through our inner solar system, it offers relatively low-stakes opportunities to practice these discrimination skills. Unlike climate science or public health policy, comet conspiracies don't directly threaten social stability or human welfare. We can afford to examine competing interpretive frameworks and develop better techniques for separating astronomical signal from social noise. The challenge ultimately reflects deeper questions about how human societies can maintain both wonder and wisdom in information environments designed to reward emotion over analysis. The sky remains humanity's greatest canvas for projecting hopes and fears, but we've learned to distinguish between the movies we create and the genuine dramas that unfold according to physical laws indifferent to human storytelling preferences. Part 15. Closing reflection, dust, myth, and the mirror of the night. So we return to our original question with the weight of evidence behind us and the infinite night sky stretched above. Is 3I-ATLAS the first sign of Project Bluebeam? The answer emerges with crystalline clarity from the accumulated data. This is a natural interstellar comet following predictable physics, while Bluebeam remains what it has always been. An unsubstantiated conspiracy theory that reveals more about human psychology than government capabilities. But perhaps the more interesting question is why we needed to ask at all. Why does a genuine cosmic visitor, only the third confirmed interstellar object in human history, require defense against accusations of artificial manufacture? The answer illuminates something profound about how we process wonder in an age of infinite information and manufactured spectacle. 3I-ATLAS represents authentic cosmic archaeology. Its unusual carbon dioxide-dominant chemistry carries messages from stellar formation processes that occurred billions of years ago in alien solar systems. Its hyperbolic trajectory connects our local planetary neighborhood to galaxy-wide processes of gravitational interaction and material exchange. Its awakening under our sun's influence provides real-time laboratory demonstrations of sublimation physics operating on interstellar materials. No human conspiracy could orchestrate phenomena operating across such scales of space and time. No technological deception could coordinate gravitational mechanics, chemical spectroscopy, and thermal physics with the precision that multiple independent observatories have documented. The universe doesn't need human enhancement to inspire awe. It generates wonders that dwarf any artificial spectacle we might imagine. Yet the Bluebeam framework persists because it addresses genuine human needs that pure scientific description often neglects. Conspiracy theories provide narrative coherence in a chaotic world, clear villains in complex situations, and special knowledge that elevates believers above supposedly deceived masses. They transform random events into meaningful patterns, accidents into intentions, observers into protagonists in cosmic dramas. The appeal is understandable, even sympathetic. We live in an era when institutional credibility has eroded while access to information has exploded, creating perfect conditions for alternative narratives to flourish alongside legitimate science. When official sources acknowledge genuine mysteries, unexplained aerial phenomena, unusual atmospheric events, technological capabilities beyond public disclosure, it becomes easier to believe that everything unusual might be artificially manufactured. But the evidence tells a different story about 3I-ATLAS specifically and cosmic visitors generally. The Minor Planet Center's orbital calculations, confirmed by hundreds of observations from dozens of telescopes worldwide, establish hyperbolic trajectories that require no exotic propulsion. The James Webb Space Telescope's chemical analysis reveals compositions that expand our understanding of interstellar ice formation without requiring artificial synthesis. NOILAB's morphological imaging documents natural comet evolution responding to solar heating according to well-understood physical principles. The convergence of independent measurements using different instruments and methodologies creates evidential weight that conspiracy theories struggle to accommodate. Believing that 3I-ATLAS represents technological deception requires assuming coordination across diverse international research institutions, sophisticated manipulation of multiple detection methods, and sustained commitment to elaborate fraud for unclear purposes. Natural explanations require only that physics operates consistently across cosmic scales. The scientific consensus emerges not through institutional pressure or coordinated messaging, but through methodological convergence among researchers who actively seek to falsify each other's conclusions through competitive peer review. The process isn't perfect. Scientific knowledge evolves through correction of errors and refinement of understanding, but it provides better protection against systematic deception than any alternative knowledge production system humanity has developed. Media literacy becomes essential for navigating the complex information landscape that surrounds events like 3I-ATLAS discovery and interpretation. Simple questions can separate legitimate astronomical findings from manufactured controversies. Who made the measurements? What instruments were used? Are the data publicly available for independent verification? Can multiple research teams reproduce the results using different methods? Applied to 3I-ATLAS, these filters reliably distinguish evidence-based conclusions from speculative entertainment. Professional observatories publish detailed methodologies, measurement uncertainties, and raw data that invite scrutiny from the global scientific community. Conspiracy theories typically rely on selective interpretation of ambiguous evidence while resisting attempts at independent verification or falsification. The broader implications extend far beyond astronomy into fundamental questions about how societies distinguish between authentic discoveries and manufactured controversies. If every unusual finding gets filtered through conspiracy frameworks that resist correction through additional evidence, we lose the capacity for collective learning and rational decision-making on issues that affect human welfare. From climate science to public health to technological policy, the stakes justify patience and careful analysis over immediate judgment. 3I-ATLAS will continue providing observational opportunities through its perihelion passage and subsequent departure toward interstellar space. More data will accumulate, peer review will refine preliminary conclusions, and scientific understanding will evolve through normal processes of evidence accumulation and theoretical refinement. But the conspiracy theories will likely persist regardless of additional evidence because they serve psychological and social functions that have little relationship to factual accuracy. They provide community identity for believers, explanatory frameworks for complex events, and emotional satisfaction for people who distrust official institutions. These functions immunize conspiracy theories against correction through factual refutation. Understanding this dynamic helps explain why patient scientific response often proves more effective than aggressive debunking in addressing conspiracy theories. Direct confrontation can reinforce persecution narratives and strengthen community bonds among believers. Indirect education through media literacy, critical thinking skills, and accessible science communication may prove more successful at preventing conspiracy beliefs from forming initially. The example of 3I-ATLAS offers hope alongside caution. Despite widespread conspiracy speculation, mainstream media coverage has generally emphasized scientific findings and safety assurances from authoritative sources. Public interest in the comet reflects genuine curiosity about cosmic phenomena rather than pure conspiracy mindset. Amateur astronomers worldwide have contributed observational data that supports professional research rather than alternative interpretations. This suggests that conspiracy theories about astronomical events may be less socially damaging than those involving health, politics, or social policy. People can believe that 3I-ATLAS represents alien technology, while still appreciating legitimate scientific research about its properties. The conspiracy framework doesn't necessarily prevent learning from genuine astronomical discoveries. Yet the normalization of conspiracy thinking about any topic creates cognitive habits that can spread to more consequential domains. If people become accustomed to rejecting expert consensus about astronomical phenomena, they may be more likely to reject expert consensus about climate change, vaccine safety, or other issues where scientific agreement matters for policy decisions and personal choices. The responsibility falls partly on scientific institutions to improve communication strategies that acknowledge uncertainty without undermining credibility, address public concerns without dignifying unfounded speculation, and maintain transparency without overwhelming audiences with technical details. The challenge requires balancing accessibility with accuracy, engagement with education, and speed with thoroughness. But the responsibility also falls on individuals to develop better heuristics for evaluating competing claims about ambiguous phenomena. This means learning to distinguish between healthy skepticism that asks good questions and destructive cynicism that rejects shared knowledge. It means understanding how scientific knowledge accumulates through peer review and replication, rather than through dramatic revelation or institutional pronouncement. The night sky offers perfect practice opportunities for these skills because astronomical events typically pose no immediate threat to personal safety or social stability. We can afford to examine different interpretive frameworks, compare their explanatory power, and develop better techniques for distinguishing signal from noise without dire consequences for being wrong initially. 3I-ATLAS continues its ancient journey indifferent to human interpretation, following gravitational mechanics that predate our species by billions of years, and will continue operating long after our sun exhausts its nuclear fuel. Its carbon dioxide-rich composition will continue sublimating according to thermodynamic principles that care nothing for conspiracy theories or institutional politics. Its hyperbolic trajectory will carry it back toward interstellar space whether we see natural physics or artificial deception. The comet serves as a mirror, reflecting our own hopes, fears, and cognitive limitations back to us with uncomfortable clarity. Some see alien visitors surveilling human civilization. Others see government deceptions preparing psychological manipulation campaigns. Still, others see natural phenomena offering insights into cosmic processes that dwarf human significance while inspiring profound wonder about our place in the larger universe. Perhaps the most important lesson is that all three interpretations reveal something true about human nature, even though only one aligns with physical reality. We are meaning-making creatures living in a universe that generates both authentic marvels and elaborate deceptions. Our challenge lies in developing wisdom to distinguish between them, while maintaining capacity for wonder about phenomena that transcend human understanding. The sky has always been humanity's greatest screen for projecting our deepest concerns and highest aspirations. Project Bluebeam represents one such projection, a story about power, control, and deception that reveals genuine anxieties about institutional trustworthiness and technological capability. 3I-ATLAS represents another kind of projection, our quest to understand cosmic processes and our place within them through patient observation and careful reasoning. Both stories will continue evolving as the comet completes its passage through our solar system and fades back into the interstellar night. The conspiracy theory will likely adapt to new circumstances and find new phenomena to explain through similar frameworks. The scientific understanding will refine through additional observations, peer review, and theoretical development that gradually converges on more accurate descriptions of natural processes. The choice between these approaches to understanding unusual phenomena ultimately reflects deeper values about how we want to relate to reality itself. Do we prefer explanations that confirm existing beliefs and provide psychological comfort? Or do we choose methods that reliably distinguish between true and false claims, even when the truth proves stranger than comfortable fiction? 3I-ATLAS offers no final answers to these questions, but it provides valuable practice in asking them with appropriate humility and scientific rigor. The universe continues generating phenomena that challenge human understanding while remaining indifferent to our interpretive preferences. Our task is learning to receive those challenges with both wonder and wisdom, curiosity and critical thinking, openness to mystery and commitment to evidence. The comet will soon fade beyond the reach of our telescopes, carrying its secrets back into the cosmic dark. But the questions it raises about truth, knowledge, and human nature will persist long after its tail disappears from view. How we answer those questions may determine whether future cosmic visitors find us still gazing at the night sky with instruments of discovery, or hiding behind theories of deception that prevent us from seeing the universe as it actually is, stranger, more magnificent, and more wonderful than any conspiracy could imagine. Sleep comes easier when facts have a home, when mysteries have methods for solution, and when the night sky remains a source of authentic wonder rather than manufactured fear. 3I-ATLAS reminds us that the universe needs no human enhancement to inspire awe. It just requires human wisdom to appreciate the difference between cosmic reality and terrestrial fantasy.